Okay, hello, welcome back. Welcome back, you beautiful people. Today, there's gonna be a continuation from the last video that we made. I missed. Let me just This is really annoying. I'm sorry. There we go. Okay. Alright, so this is going to be a continuation of the last video where I've talked about, well, I promised that I'll talk about function pointers, but I never really got around to it. So I'll just make a quick video now, just about mentioning function pointers a little bit. So, like, functions are basically pointers in a way. So, if you think about it, like, what is a function, right? A function is basically it's basically, so if you think about a function, it's just like designates a segment in memory, right? Right? It's basically just a segment in memory that it basically is just like a little designation that points to a segment in memory where some other code is running, right? So in and of itself, a function is in of itself a pointer. If that makes sense. So basically, oh crap. So it is in of itself a pointer, right? So it basically is just something that points to a memory location. So basically, if I designate a function like void, and I give it a name, it basically, like, let's say do stuff like this, it basically says that, hey, there in this, like, this is an alias, right, for the memory address right here. So it basically says that, hey, at this memory address with this alias, there is some code that needs to still be run, so please run it. You know, that's basically kind of what a function is, in a way. So, we can basically then, so every function gets called with these, right? So this is basically how we call a function. So if I make function do stuff, for example, and I give it a void amount of arguments, so there is no arguments provided, and let's say it prints test, right? So here, basically what this is, it's basically saying like, hey, at this memory location there is this of code right here that needs to be run. We can obviously call a function, which basically is, we can basically call a function. The way we call a function is basically by saying do stuff, and we put these right here. So these two brackets right here basically tell the compiler that we want to call our function there. As you can see, it will get called. But we can also treat functions as, for example, we can also treat functions sort of as variables in a way. So repeat after me. Let's go slowly. So here I can make a pointer. So this is going to be void, right? And then, so this is going to repeat after me. So the way we designate a function pointer is we put brackets, and then this is going to be a return type. And it needs to match with the return type of your actual function right here. So let's go void, right? You can have a space here. So this right here is where your variable name goes. or your alias goes. So let's do that. So let's do that. Put a star right here. This designates a pointer, just like you would, for example, with like char pointer string, right? Right, this little star right here designates a pointer. So let's go back to our function and let's do that again. So void, because our function is void. Then we can have optional spacebar, not necessary, brackets and star to designate a pointer, and this is our variable name. So let's give it a name. Let's say alias, right? There we go. And then right here, I think we can. Oh, this is passing to parameters. I think we can just. Yeah, so this is a void pointer. So we actually want a void pointer because it doesn't return anything. So void pointer alias. Okay, so in here it's a bit different. That is, I made it a bit confused. That is how we input functions as a parameter. The way we do it is that this returns a void. So this needs to be a void pointer. So there we go, because our function returns a void, and then we just say patara right here, and then we put it equal to the memory address of do stuff, which we can do like this. As you can see, it returns void right here, so we make it a void pointer right here. So basically, yeah, there we go. Basically, I'm declaring a pointer that can point to any type in memory. And but also because there is void right here. If I put it int right here, it would basically be also okay, because void right here is basically, you can cast any pointer to a void pointer. But I think more correct would be to cast this as an integer, right? Yeah. So it's still in type void. There we go. So it takes void as parameter, so that's why. The return types will become important when we put parameters. So if you want to take a function as a parameter to a function, you need to specify the return type, then the variable, then the parameter name, and then obviously the arguments as well. When you're doing it like this, it doesn't really matter. You kind of just specify, we can just specify a void pointer, and you can just get away with that. So let's do that. So void star pointer, and then the ampersand memory address of do stuff, right? And then we can basically call our function via a pointer. So if we just say pointer, yeah, so right here, as you can see. So we can basically get the memory address of this function right here. And then we can basically, yeah. So it basically points to our function. Oh fuck. This basically just holds the memory address of our function right here. So it doesn't really, it's not really useful in any way. So it's not really useful in any way. You can dereference the pointer. But yeah, it doesn't really do much, does it? So you can dereference the pointer, but this is kind of just not really that. You can't really do anything meaningful with this as of now. I'm just showing you that, like, yeah, you can get the memory address of your function and assign a pointer to it. But since this is of type void, we can't really do much with this. So yeah. Well, I can show you how we can make this a bit better. So this is like basically just saying that because this just holds the memory location, right? So if we just simply print this, it will just show us the memory location of that function. So for example, like you can do that, and it'll just spit out like a hexadecimal value of, like, as you can see right here. So this right here is like the memory address of the function right here. So it'll just spit out. So this right here is basically your memory address. So this number right here is the location in the memory where this function is located at. That's basically what that is. I mean, you can cast this into an int pointer and dereference that, because I mean it is, but I mean this might probably give you some weird undefined behavior though. Yeah, so it's just gonna spit out like these weird numbers at you. So there's really nothing weird, nothing that you can really do with this. I'm gonna show you. So as you can see, it will just spit out memory locations and a bunch of like addresses where the function is located at when it gets compiled. So nothing that useful, but I'm gonna show you something that is very useful. So we can basically take in as take these as parameters to a function, right? So we can basically, if we have a struct, there is an example I can give you. So here, let's have a struct, and I don't know, let's say, I don't know, functions, right? So the struct called functions here, and let's assign our first function. So void, and then here you put this right here. So let's repeat after me. So we can create a field that takes in a function pointer. So let's do that. So we can assign this function to belong to a member of this struct. So how do we can use that through a function pointer. So we can basically say void, and then put little brackets, and then put in the star to declare a pointer. I'm just gonna say ptr, and right here you declare your parameters. So void. There we go. So now you have successfully declared a function pointer. So what now we can do is we can make an instance of this struct functions fun, and then right now I can basically assign fun.pointer. I can assign do stuff to that. And as you can see, I assigned, for example, as you can see, I have assigned the pointer in our struct to our function. And now I can go fun.pointer, and I can call this, because this is a callable now, as you can see. So now this will basically do the same thing. It will just print test, as you can see. So you can treat functions as pointers. I believe this actually worked, but I was being a bit of a dumbass. So I think we can also make it like this. We can just say void pointer void, and then make it equal to do stuff. Yeah. There we go. So this is actually how you declare it. I'm sorry, I was being kind of a doofus. But yeah, you can also make a void pointer, call it pointer, and then get the memory address of do stuff as well. That works too. And since this contains memory address, we can basically just point it to... We can basically just use this pointer to assign it to another. But this gets very confusing. I don't want to declare a million pointers. Let's just keep this very simple, okay? We have a function do stuff. And I was being a bit of a doofus last time, so sorry about that. So the way we actually correctly declare these function pointers is we say your return type, specify a return type that would be void. This one has to match with this, then put little brackets and a star, and this declares your alias for your function. And then here make another brackets, and then here goes your parameters, void. And make it equal to the function that you wanna equalize it. Good. Now I can call alias and do it like this instead. So I can actually call it like this by proxy. So as you can see, I can call my function by proxy now. This is, and I hear you asking, well, why is this useful? Like, why would you want to do this? Well, let's say this is very useful for creating wrapper functions. So for example, if I have a function called a wrapper, for example, that I want to run a function while also simultaneously doing something else when the function is running, I need to take a parameter as a function, and this is actually how this actually perfectly will lead in to the next lesson I prepared for you, which is about multi-threading in C, which we will need the knowledge of function pointers to be able to use parallel execution in our C program. Because if you either ignore these two include files for now, that will just ignore those. Just ignore that. That will come in later. If you are either using, let's say, pthread or if you're Windows, and if you're on Windows and you're using Windows 10 SDK, it will be in your process.header. So your multi-threading will be here in pthread, and on Windows it's in process. And as you can see, there is start. What the hell? So as you can see, the start. Yeah, so there we go. So there is the pthread create, as you can see. Pthread create takes in a pthread type t, which is basically a function pointer. So no, this is a pthread. So a pthread dot create takes in a pthread t. Yeah, this thing. But we're not going to talk about that now. So if you're using pthreads, if you're on Linux, you're probably going to be using pthreads. So pthread.create, as you can see, takes in a memory address of your pthread variable, then a bunch of attributes, which is basically just like your memory size, whatever. And as you can see, right, this little thing right here, as you can see. So it basically takes in a function that returns a pointer to void. So it returns a void pointer. This is the instance variable name right here. So this is your parameter name. And this right here is a parameter. So what this is telling you right here is that this wants a function that returns void pointer and takes in void pointer as a parameter. And then these arguments right here basically are the arguments that are passed into the function right here during runtime. That's basically what this means. So that's the reason why I'm covering these function pointers with you. You know, and what this pthread.create is, so pthread create right here is something called a wrapper function, because it takes in another function as a parameter. It basically wraps another function, basically. So that's kind of what the terminology is there. But let's create a simple function pointer for now. So let's say I want to create like a void, right? So void, let's say wrapper, right? So this is our wrapper function. So this function needs to take in a function as a parameter, because we, let's say, want to print like a bunch of shit before we execute the actual function or do some stuff. You know? So what do we want to do? So we need to specify the return type first. Since I don't want my function to return anything, I'm going to specify void. Now I want to put the little brackets. This is where you will put brackets and a star. Just do it. Brackets and a star. Do that automatically right now, because you will always do it like this. Here goes the name of your parameter. I will name it func. And then here goes your what are the parameters that the function is supposed to take. So these are unnamed parameters or untyped parameters, which means you only just pass in like the raw data. So int for example, you don't give them like variable names, right? So you can just pass it like this. You can have them be untyped. But for now, obviously, just for simplicity's sake, let's just put void, you know? And then here we can so now we have our function that takes in another function. Specifically, it returns void and it takes in void. So it's a very simple function, doesn't return anything, doesn't take anything as parameters. So for example, here, let's say I want to say, do some stuff. So do some stuff before calling function, and then I want to call my function. Oh, what am I doing? What am I doing here? Now what I want to do is I want to call my function, right this, and then I want to say right here, I want to be like, do some stuff after calling function. There we go. So this is kind of stuff. This is kind of why function pointers would be useful. So for example, if we want to do some stuff before, then we call the function, and then we do some stuff after, usually kind of related to memory. Great, so let's create our function that we will pass in. So we can create anything, so we can run virtually anything between these two. We can run anything between these two print statements. So let's say make a void. Let's say do stuff. And void, because that's the parameter, that's what these parameters are telling us right here. And let's say that I want to print, let's say I want to print let's say I wanted to print something 5 times. So let's say I want to print my eye, for example. My eye, let's say 5 times, right? So I want to print this eye over here in this loop 5 times. So I want to run this for loop in between these two print statements. It basically this is useful for like making your code more general. So what happens here is now we can call our wrapper function. So let's go ahead and call your wrapper. And it will tell you that it requires a void return type and a void parameter type. So we have that. We have do stuff. So let's just go ahead and pass that in there. So this is our function that we want to run. And as you will see, it will print this. Then it will print 0, 1, 2, 3, 4. And then we'll print this. Yeah, there we go. All I have to do is just put some new lines here because this is unreadable. So let's do that right now. It does work, but let's just print some new lines here, and there we go. Yeah. I just want you to be able to be easily read. So as you can see, there we go. Do some stuff before calling the function. Gets called here, then it prints 1, 2, 0, 1, 2, 3, 4 because it calls this function right here. So this is where the function gets called, and then it does do some stuff after calling the function. So as you can see, this is how, in simpler terms, function pointers work very simply. You can also put in, let's say, you can also make it a bit more advanced. You can also take in parameters. So for example, I can make my function, let's say void do stuff, and I can have this function taken an integer, right? So I'm just gonna say I want a const int that's gonna say count, right? And I want to run a for loop, for example, the count amount of times, right? So I want to pass this in during, like, dynamically. So I want to run a count amount of times, and I wanna print my I count amount of times, right? So how would this function pointer actually look like? Well, here, the thing about function pointers is that you always have to remember, I'm actually going to write this. So I'm going to say, so let's say void func right here. So I'm gonna split it up for you. So this right here, so let's analyze this. So this is a parameter. So this is a pointer to a function, right? And that, so basically a function that returns void and has one parameter of type void. So that's basically what this is, what this means. Let's analyze our p thread over here. So pthread create. Let's analyze this function right here. So what does that actually mean? Well, I'm gonna give you. So it's something like this, right? So it's something like this. So I'm gonna actually explain what this means. So this means a point. So what does this actually mean? It sounds a little confusing, but it's actually not. It's a pointer to a function that returns void pointer and has one parameter of type void pointer. So that's what this means. So if we want to declare, for example, a function that takes in a parameter, for example, something like this, I think you kind of start to get the point. So this is a pointer to a function that returns void, not void pointer anymore, and has one parameter of type, right? Parameter of type const int. I think you're starting to get a point a little bit, right? I think it's starting to make sense what's happening here. So I want to take in a parameter const int. What you have to also always remember to pass parameters to function pointers separately, right? What does that actually mean? Well, we can't just pass it in like instantly, right? We need something called an untyped parameter. And this is where our wrapper function comes in. So our wrapper function doesn't return anything. And our wrapper function right here needs to copy these exact types. So it returns void. Okay. Let's declare our alias for the function. It will be func. And then here, what parameters does it take? Well, it takes a constant. So it takes in a constant. Awesome, epic. Great. And we call these untyped parameters. It just takes in a const int, but we don't actually need to give it a type. Well, no, these are not untyped variables. Sorry, these are parameters that don't have a name. So these are unnamed, like anonymous parameters, or unnamed parameters, not untyped parameters. God damn, I'm dumb. No, untyped parameters would be without type. These are unnamed variable parameters, or anonymous parameters, if you want. So these parameters are unnamed, which means they don't actually have a name. So this is a named parameter right here, and this would be an unnamed parameter. We can keep it like this. What we want is basically a const int and arg. So we name it right here. So we put an unnamed parameter here to basically tell our pointer what our function, what our function that we're passing in here basically takes. And then we put a named argument right here that we pass in separately. So if your functions have, for example, arguments like this, or parameters, you're always going to have to put them here. So if this, for example, had let's say a const char pointer, what am I clicking on? A const, let's say char pointer, let's say char pointer name, you're gonna have to put this here. So here you're gonna have to go in and say const char pointer, and then here you're gonna have to go here and say const char pointer name arg. So right here you're gonna have to do it like this to be able to pass them separately. Or you can simply just put these three dots right here, which is called a vararg, and then you can pass the amount of these arguments to this function. But we will talk about these a bit later because I don't want to complicate this even more. And since this is more aimed at beginners, you don't bother about varargs, okay? Just let that completely release that from your head right now. And we'll just pass in a const int argument right here. So let's do this as before. So let's call our printf function and say do stuff before calling function, and then we want to call my function. So I'm gonna say func. So I want to say func right here. Let's just remove this because this is unnecessary. It's only a const integer. So func right here. And as you can see, if I put this, it'll tell me that it requires an unnamed type of const int. Oh, sorry, of const int. Well, we have that. It's an arg. There we go. We just simply pass the arg right there, and then we can just say printfs, and then say do stuff after calling function. There we go. Awesome. So let's test out our little function here. Okay, well, our wrapper takes in this, and I want to print as many numbers as I want, right? That's kind of the whole point. So this function will allow you to do just that. It will allow you to actually print how many numbers you want. So let's do that. So wrapper right here, as you can see, it takes in a void return type and a const int parameter. Well, we do have that. It's called do stuff right here. We have that function right here. So beautiful. So let's put that function there. But obviously now we can't just leave because we also have to pass in the second argument. As you can see, it requires two. So it requires a pointer, and it also requires an argument. So we're gonna give it. I want to print it 5 times. So as you can see, this is our function that we want to run, and this is the amount of times we want to print I, or how many numbers we want to print. And as you can see, it prints 0, 1, 2, 3, 4 right in the middle there where I called it. If I, let's say, put 10, it will print 10 numbers from 0 to 9. There we go, from 0 to 9. If I say 100, it will print numbers from 0 to 99 between those two. There we go. As you can see, I can put whatever I want here, and it will always run between these two print functions right here, as you can see. So that's kind of like the beauty of using these function pointers. So, okay, so this has already been, I've been recording for around half an hour, so I think it's time for a recap. I just wanted to make a quick little video for you covering these functions because we're going to talk about multi-threading, and, you know, more advanced concepts in general will require you to know what function pointers are. So, without further ado, why am I deleting it? I'm a dumbass, I'm sorry. So what have we covered? So let's summarize. So let's summarize. To declare a function pointer, it always goes return type, then name, then alias name, and then parameters, then unnamed parameters. Unnamed parameters. Parameter/parameters. There we go. So this is the general boilerplate. So it goes return type, like this alias name, and like this unnamed parameters. Okay. So function pointers always have to match your function. So for example, right here, return types, obviously this return type and these parameters, so right here, so this return type right here and this unnamed parameter/parameters right here, needs to match with your actual function that you're passing into your parameter. There we go. That's a very important factor. Next, so example is a multi-threading in C, for example, requires function pointers. So multi-threading in C. So multi-threading in C requires function pointers. There we go. And it allows us to do complex tasks very easily. And that's what the main benefit of function pointers is. So remember, I'm going to go this again. So this is how you declare a function pointer. You put a return type, a name of your parameter here, or your alias name for your function, and then unnamed parameter. And then, and then you pass in the other one separately. Always make sure to do it like this. All right? Then, another important fact, if your function pointer has an unnamed parameter, let's say unnamed parameter, then you have to pass it separately, especially when dealing with your wrapper function right here. Always remember, if your function pointer has an unnamed parameter, you always have to pass it separately to this function pointer, like this, right here. Okay? So remember that. And yeah, I think that's it. I think that's it for this lesson. I actually like this. This was a nice little quick video. Next time I'll probably talk a bit more about multi-threading, because this is perfect. That's actually the reason why I wanted to talk about this now, because this perfectly leads into our next lesson about multi-threading and using p-threads. Let me know if you need these functions to be more explained, or if I need to make more videos covering the functions and see a bit more, because I'll always be happy to do that. Obviously, it's fine. It's not that big of a deal. It's just maybe some people just need a bit more explanation. But yeah, so go ahead and do this yourself. I hope that you at least tried doing this yourself to kind of understand how this all works and how we actually pass in function pointers. Because in C++, which is going to be my next series, there will be lambdas and lambda expressions, and we will need these function pointers even more. So yeah. I think that's it for this video. Make sure to like, obviously, just slap it on down there, to show that, maybe this is good and it's helping you out. So that's a good way of showing me that this is helping you, is to like tickle that, the tickly the little like down there, and then maybe just subscribe, bro. Okay, just let's be real. You want this. You need this in your life. Come on, bro. This is like bro. You need this. You need to know all about the C language. Okay, you need this in your life. Trust me. Nah, but subscribe though, for real. Okay. Like come on, come on. Share that goodness with the world. All right. But yeah. Anyway, I'm gonna go now. And I'm gonna go and cook a bunch of mosquitoes that I found in my garden in a pot and make a soup out of them. So, see you in the next video.